Hello, everyone. Welcome to the Chapter 8 test review. Let's just get right into it. There's a lot going on here. So, number one, the shelf life of a particular dairy product is normally distributed with a mean of 16 days and standard deviation of 4 days. Using the empirical rule, what percent of products last more than 24 days? Using the empirical rule, what percent of products last less than 12 days? So, the empirical rule, remember, is kind of just 68, 95, 99.7 rule. So, we're going to need to draw this out. All right. So we know 16 is the average here in the middle, and standard deviation is 4. So we're going to go 20, 24, 28, and then we got to subtract some 4s as well. So 12, 8, and 4. All right, so now it's asking, the first part is about lasts more than 24 days. Before I actually do that, let me label these. So, you guys can remember each of these regions, because you're going to need to know these regions. So we know, again, we have 34% here, 34 here. This one's 13.5, 2.35, and then 0.15. Same thing on this side, 13.5, 2.35, and then at the very end, 0.15. All right, so these are the ones we're looking at. The first one is about lasts more than 24 days. So 24 is here. So 24 is going to be these two regions, 2.35 and 0.15. So that's going to be 2.5 percent. All right, using the empirical rule, a percent of product less than 12 days. So 12 days is here. Less than 12 days. So it's these regions. So that's going to be the 13.5 plus 2.35 plus 0.15, which is 16%. All right. We have something similar in number two. Number two, 68% of values lie between blank and blank. So you might not have to do the whole picture, but it can't hurt. So let's go ahead and draw this one out as well. All right, so we know we have 5.1 in the middle, and we have 0.7. So we gotta add 0.7 to 5.1. So let's see, 1, 2, 3. So this will be 5.8, 6.5, 7.2. And then backwards, we're going to have 4.4, 3.7, and 3.0. But it's a 68% of values lie between blank and blank. Well, 68 is the middle. First standard deviation to first standard deviation. So that's in here, of course. And so we know that's from 4.4 to 5.8 according to our number line. So 4.4 and 5.8. If it's a 95%, that would be 3.7 to 6.5. If it was 99.7%, that would be from the 3.0 to the 7.2. The mean life of a tire is 35,000 kilometers. Standard deviation is 2,500 kilometers. The 95% of all tires will have a life between. So again, kind of following the empirical rule here. Very similarly to the last question. All right. So we know, again, the middle is 35,000. So we got to add 2,500 to it. So we got 37.5. Adding another, we have 40. I want to just leave these in thousands. Then we have 42.5. If you subtracted it, you'd have 32.5, 30,000, and then 27.5. So you're going for the 95th percent. So 95th is going to be the second standard deviation to the second standard deviation, which is these ones. So you're going from 30,000 to 40,000 by the looks of it here. So our answers are going to be 30,000 to 40,000. All right. I'll make a couple little notes here as well. -2 standard deviation to +2 standard deviation. And this one, 68% is -1 standard deviation to +1 standard deviation. All right. And this one's, of course, going to be from the third to the third. So from -3 standard deviation to +3 standard deviation. So we'll draw this one out. We have now the distribution, means 112, standard deviation is 14.5. So we'll look at that one. All right, so we have 112. And of course, again, 14.5 is what we're going to add. So 112 plus 14.5. We're going to have 1, 2, 3. 126.5, 141, and then 155.5. We're going to need that number. That's the third one. We're going to go 3 backwards as well. So 112 minus 14.5. We have 97.5, 83, and 68.5. And so in this one, we're going from the third to the third. So it's going to be the 68.5 to the 155.5. So, yep. So you remember that, hopefully. Go ahead and fill it in just like the other ones. There we go. Yeah. So our answer, 68.5 to 155.5. I didn't leave any blanks to write it in, so I have to write them myself there. All right, standard normal curve has a mean of 0 and a standard deviation of 1. This is just a fact, straight from the notes. Okay, so plain old fact. You guys knew that. The weights of 3-year-old boys are normally distributed with a mean of 19 and standard deviation of 4.1. Find the z-score that corresponds with boys' weight of 29. Okay, so z-score formula, let me put the formula over here first, right? So z equals x minus the mean divided by the standard deviation. So in this case, z equals, we have x is 29. We've got the mean of 19 and the standard deviation of 4.1. So 29 minus 19 divided by 4.1. So this is 10 divided by 4.1, which is 2.44. Make sure you correctly round the 2 decimal places as well. All right. Monthly utility bill in a city is normally distributed with a mean of 90 and a standard deviation of 11. Find the value of the utility bill if it corresponds to z-score -2.53. So again, same formula, right? Z-score formula, x minus the mean divided by standard deviation. In this case, it gives us z, the mean, and the standard deviation, and it's asking for us to find x. So we have -2.53 is z. X, we do not know. Mean is 90. Standard deviation is 11. So when we solve this, what we're going to do is we're going to go ahead and start by multiplying both sides by 11 to cancel out this 11 here. So 11 times -2.53 is -27.83. So let's see. So this would be -27.83 equals x minus 90. And then, of course, we need to add 90. And so when you add 90, we get 62.17. X equals 62.17. So that means the utility bill would be $62.17. All right, using the normal probability table, find the probability corresponds to a z-score of negative 1.17. So this is just using the table straight up. There's no math here, just got to go find this. So z-score negative 1.17. So let's see here, negative 1.1 is right here. Oops. And then 1.17, we got to go over. So this is 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7. So it's going to be 0.1210, 0.1210. Let's do it again. We're going to do the same thing. Z-score of negative 3.04, negative 3.0 here, but then 304. So this is 0, 0, 0, 1, 0, 2, 0, 3, 0, 4. So that's 0.0012. All right, so a couple of easy ones we should be able to do. Which z-score has a probability of 76.73%? So remember, know that this is 0.7673, right? That's what 76.73% is in decimal form, which is what the z-table has, all those probabilities in decimal form. So let's look for this on the z-table, 7673. So obviously it's not here because these are all 0.00s, right? So 7673 is going to be on this side. Again, we're looking through all of these. We're looking for 7673, and here it is. 7673 is there, which corresponds with the z-score of 0.73. 0.73. So 0.73. All right, not bad at all. A set of magical wand prices are normally distributed with a mean of $70 and a standard deviation of 7. A blackthorn wand has a price of $61.20. What proportion of wands are higher than the price of the blackthorn wand? All right, so now we're getting into the really like fancy schmancy stuff here. All right, so first thing we're gonna do is we're gonna find the z-score. We have our x value, we have our mean, and we have our standard deviation. So 6120 minus 70 divided by 7. So let's see what that is. So we have negative 8.8 divided by 7, which is negative 1.26. All right, so now remember that's our z-score. So we're going to have to go to our z-score table, negative 1.26, negative 1. Let me erase some of this stuff. All right, so negative 1. Oh, come on, man, we'll do this. Negative 1.26. So 20, 21, 22, 23, 24, 25, 26. If I scroll up, that should be under the 0.6. It is, okay. So 0.1038. Remember, this is below. This would be the less than value. We want proportion of one's prices that are higher. And if it's higher, we're going to have to do 1 minus that value. So 1 minus 0.1038, which is 0.8962. 0.8962. There you go. So if it says lower, then this is the value you keep. You keep the value that you get from your z-table, because all those numbers in the z-table are the lower side, the left side. If it's higher, we have to do 1 minus that amount to find what essentially is the right side, because higher represents the right side of our mark. All right, give a normal distribution with mean, blah, 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 find this. Okay, so yeah, basically the same thing, just without like context, without like a word problem. So let's go ahead. Z-score equals, our x value is 143 minus our mean of 123 divided by standard deviation of 18. So this is going to be 20 divided by 18, which is 1.11. So again, we're going to go to our z table, look for 1.11. Remember, it's positive in this case. So 1.1 is here. This is 1, 0. This would be 1, 1. So 0.8665. So 0.8665. But notice it is above, it is greater than. So that means we have to do 1 minus that number. 1 minus 0.8665. So that equals 1335, 0.1335. All right, let's do it again on the next one. So the next one we have z equals, our x value is 89. Our mean is 80. Our standard deviation is 16. So this will be 9 divided by 16, which is 0.5625. So remember it's the z-score, so we got to round it. So 0.56, 2 decimal places. And then we're going to go find that z-score on our z table, 0.56. Again, it's positive. 0.5 is here. This we have, this would be 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5. Hold on. 5, 0, 1, 2, 3, 4, 5, 6. You guys can see that right there as well. So 0.7123. 0.7123. And it is below. So then that is our answer that we keep. Okay. If it's ever higher or above, we do the 1 minus that number. But if it's below, we just keep that number, which is nice. All right. Given a normal distribution with mean and standard deviation like that, we're going to find the probability between these numbers here. So same thing, we're going to do it twice basically, and then just subtract our values from each other at the end. So 2 z-scores, one for 27.5 and one for 38.1. So z equals, we'll start with 27.5. 27.5 minus the mean, 31.5, divided by standard deviation 6. So this will be -4 over 6, which is negative 0.67. So the other z-score, z equals 38.1 minus 31.5 over 6. So that's 6.6 divided by 6, which is 1.1. All right, so again, those are z-scores. So let's go to the z table now and find the probability. So we're going to look at negative 0.67. Negative 0.6, 0, 1, 2, 3, 4, 5, 6, 7. So you have 2514, 0.2514, and then the one at 1.1. Now note that this is 1.1 flat, this is 1.10, and 1.10 is right there. So 8643, so 0.8643. And so because we're finding the area in between these, we subtract these from each other to find what the difference between them is. So obviously, again, always take the bigger one from this minus the smaller one. So 0.8643 minus 0.2514. And what do we get? We get 6129, 0.6129 as our area in between. All right. Very similar question with number 15. A set of average city temperatures in December are normally distributed, means 21.1, and a standard deviation is 2. What proportion of temperatures are between 19 and 24? Okay, so basically, again, the same problem. So z equals we're gonna start with 19. 19 minus the mean, 21.1, divided by standard deviation, which is 2. So this will be negative 2.1 divided by 2. So that's negative 1.05. So that's our z-score for 19. Now we'll do it again for 24, just like the last question. 24 minus 21.1 divided by 2. We got 2.9 positive 2.9 divided by 2, which is 1.45. All right, so let's go find again the probabilities on the z table with those. Negative 1.05, negative 1.0, 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. So that's 1469.1469. That didn't help. All right. And then we have positive 1.45. So 1.45. So 0, 4, 0, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 9, 2, 6, 5. 0.9265. And just like the last one, we're just going to subtract them from one another. And so let's see, we get 0.9265 minus 0.1469. We have 0.7796. All right, very good. All right. Ooh, it's a handful. Number 16, the heights of adult men can be approximated as normal with a mean of 67 and a standard deviation of 3. 10% of men are shorter than what weight? Okay, so this one's kind of a reverse problem. So if you imagine it here, we have 67, and then standard deviation is 3, so this would be 70, 73, 76. And then backwards, this would be 64, 61, and 58. And it says 10% of men are shorter than what height? So we're looking for the shortest 10%. So we don't know exactly where that is, but we know it's roughly about this region, right? This is what we're looking for, the shortest 10%. And we're looking at what X value is that cutoff at? So what we need to do is this is a reverse question. So 10% is what we know. We have to go find 10% on the Z table. So these are like, as you can see, the 90s and 94%. We're looking for 10%, so 0.10. 0.10. Look, okay, so right here. It's between these two, but this one is closer. So this is the z-score we're going to use. Now, it's again, we're not using 0.1003. We're using the z-score that it goes with. So that's negative 1.28. I think, right? 0, 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So it's negative 1.28. So that's our z-score. X is the value we don't know. The mean is 67. The standard deviation is 3. So we have to just solve this for X at this point. So the hardest part was just taking this 10% and finding the z-score of it. That's the hardest part. But we can do that, really. It's really not too bad. All right, so we're going to multiply both sides by 3. So 3 times negative 1.28 is negative 3.84. X minus 67. So now we're just going to add 67, of course. So add 67. Oh my gosh. Negative 3.84 plus 67. 6316. X equals 6316. So that's the value here. That's the value where 10% of men are shorter than 63.16 inches. So there's your cutoff. 10% of men are shorter than 63.16 inches. All right. Similar question here, but it's kind of the reverse side of it. So on this one, looking at the top, it says 90% of people have an IQ more than. So we're looking at the top 90%. So it's kind of similar, but a little different here. Means 100, standard deviation is 15. So let's draw that out. So again, oh my goodness, every time. I guess this is the problem about being right-handed on the screen because the right hand side has a scroll. So if I touch the scroller, it bounces. 115, 130, 145, and then we have lower end, so 85, 70, and then 55. So it says 90% have an IQ more than what? So this is referring to the top 90%. So the top 90% is all of this, right? So this is what we're looking at finding. However, no, let me leave it. Let me just color it with this actually. This is what we're looking at. We're looking at trying to figure out what X value that cuts off as. So you can see I drew a line here, but I don't really know where that line's actually supposed to be. But this is 90% on this side. So, but remember, what we're going to do is we're not going to look at 90% though for the Z table because 90% is represented by the right side. The Z table doesn't work with the right side. It works with the left side. So if this is the top 90, that's an indicator to us that this is the bottom 10%. So it's actually a very similar location, right, to what we had in the last problem. And we would do the same thing. We would go in here and we'd look at for 10%, but we already know where it is because we just got it from the last question. It's at negative 1.28, right? So it's actually going to be at the same Z score, right? So that you can see how similar these questions really are. So Z-score is still negative 1.28 equals x minus 100 divided by 15. So again, just solve it by multiplying by 15 and then adding 100. $80.8. So that's where this mark would go, 80.8. All right. We fill in that in that I erased by accident. All right. So when you have these questions, if it says the lower percentage, that's directly the number you're going to look for in the Z table. If it says the upper percentage, you have to kind of convert that to what is the lower percentage. Because if you actually look in here for 90%, right, and you find 90% is right about here, this is probably the closest one to 90%. You'd use a Z-score of positive 1.28, but that, remember, would be all the way on this side. That's not the top 90%. That would represent the bottom 90% and the top 10%. So that's a little bit backwards. We're looking for the top 90%, which corresponds to the lower 10%. Always the lower piece that's represented on the Z table. You have to remember that. All right, 2 more to go. Pretty much the same thing, just without like the word problem. So we have, we're gonna look for the Z-score. So this is probability again. We know that the probability is 0.35 and it's less than K. So this is the lower 35%. Lower 0.35. So we need the Z-score that corresponds to that. So again, we're gonna look through here for that 35%. So we're looking for 0.35, which is between these two. And this one's technically closer. The 3483 is technically closer to 35. And that's at negative 0.39. So that's Z-score negative 0.39. So let's use it. Negative 0.39. Our X value is, we don't know. That's what we're solving for. Mean is 20. Standard deviation is 2.7. So remember, it's kind of like you have to just find the z-score. You have to know what percent you're looking at, go find the z-score that goes to that percent, and then use it. From there, it's pretty much just an algebra problem again. So we're going to multiply by 2.7. Which is negative 1.053. And then just add 20. So we get 18.947. X equals 18.947. All right. Now this one, last one, similar, but notice how it's a little bit different. This is the upper, because greater than upper 25%. So upper 25%. So we need to think how the lower end, lower is really 75%. So that's, remember what matters. We can't use the upper percentage. We have to use a lower percentage. So if it's the top 25%, then we're going to use a z table and look at the lower 75%. So in here, you're not looking for 0.25 because 0.25 is the upper. You're looking for 0.75. So we're going to look for 0.75, which is right between these two. And it looks like they're close, but this one's closer, 7486, which is corresponding to 0.67. Yeah, 0.67 is your z-score there. 0.67. Okay, so we have 0.67 equals x, we don't know, minus the mean, 100 divided by standard deviation, 24. So again, final question, just an algebra problem. So we're going to start by multiplying 24. All right. 24 times 0.67 is 16.08. Equals x minus 100. And then, of course, we just have to add the 100. So that means that we'll have x equal to 116.08, sorry. All right. Now that's the full version of all this, which takes way too much time. So what I think I'm going to do is I'm going to have to show you the shortcut. And what I'll do there is I will just do this all over again, but I'll do it entirely on the calculator to show you guys that because you're gonna want to know that skill. All right. But the only problem with that is you wouldn't be able to necessarily, not all of you would be able to do that on the final exam. Just because of the limited graphing calculators we have. But you could use Statsmetic, but you wouldn't be able to use Statsmetic on the final exam because you're going to be locked on your Canvas page. You won't be allowed to leave it. So you should know how to, you can answer every single question by hand like we've done here. But if you have the resources, we're going to use the calculator and I will show you that in a separate video because this one's already too long. So I'll see you guys in that video. Bye for now.